Hello students, this is Ingrain. Welcome to the channel and welcome to the new video. Today we will start periodic table of class 10. In this chapter, you're expected to learn the classification of elements, salient features of the modern periodic table, periodicity and periodic trends in properties, which we will cover in various episodes. In today's episode, we will cover the classification of elements. Before proceeding with the chapter, if you haven't subscribed our channel yet, do subscribe the channel and press the bell icon to get all the latest updates. First, let us understand what was the need of the periodic table, why it was required at all. Elements are the basic unit of all matter. Thus, to study the characteristics of elements, there was a need to organize these elements. The elements were grouped into families that showed maximum resemblance. Before all naturally occurring elements were discovered, the periodic table was used to predict the chemical and physical properties of the elements in the gaps on the table. Today, the table can be used to predict properties of elements yet to be discovered, although these new elements are all highly radioactive and break down into more familiar elements almost instantly. But this periodic table was not formed at one go. Gradual developments led to the formation of the periodic table that we see today. Previously, earlier chemists classified elements based on metallic and non-metallic character. And then Dauberrenner tried to classify the elements by grouping them in three, called the triad. Then Newland came, who said that the elements can be arranged in series of 8, which is called the law of octaves. After that, Mendeleev said that the properties of elements are the periodic functions of the atomic weights. But this underwent some reformation, and finally Moseley told that the properties of elements are the periodic functions of the atomic number. We will study all of them in the upcoming slides in detail. In ancient days, the early humans classified elements as air, water, earth, and fire. But with the advent of science, the earlier chemists classified elements on the basis of metallic and non-metallic character. But we all know certain elements have some dual character, and thus this method was rejected altogether. Then Dauberrenner in 1815 arranged the elements in group of 3 called triads. For this, the elements were arranged in increasing order of the atomic weights in such a way that atomic weight of the middle element was found to be the average of the other 2 elements of the triad. As you can see here, lithium, sodium and potassium are arranged in a triad because atomic mass of lithium is 7 and that of potassium is 39. The average of 7 and 39 gives 23, which is the atomic mass of sodium. Like this, the other triads of chlorine, bromine and iodine and calcium, strontium and barium were formed. But this method was also rejected as it did not hold true for all elements. Then Newland, in the year 1864, arranged elements in series of 8 in increasing order of atomic weights. He observed that the physical and chemical properties of every 8th element was the repetition of the first element, as you see in the musical scale, and this is known as the law of octaves. Here you can see a musical note is given, sa re ga ma pa dha ni sa. Here you can see the first and the 8th note is same. This happens with the elements as well. Hydrogen, similar to fluorine, which is similar to chlorine. This was the concept, and based on this concept, He prepared his own table, which is known as the Newlands Table of Octaves, and that looked like this. But this was also rejected because of certain reasons. This table, as you can see, holds true only till calcium. Moreover, it placed two elements in the same slot like cobalt and nickel and placed it in the column of fluorine, chlorine and bromine. Here you can see cobalt and nickel placed in the same group as fluorine, chlorine and bromine. But they have different properties. Moreover, iron, which has resemblance with cobalt and nickel, are placed far apart. Iron is located here, whereas cobalt and nickel are located here. Then just after 5 years, in 1869, the Russian scientist Mendeleev stated that the properties of elements are the periodic functions of the atomic weights. He arranged them so that the groups of elements with similar properties fell into vertical columns in his table, which look like this. This arrangement led to many gaps in his table, but in spite of thinking this to be a problem, he thought the elements belonging to the gaps are not yet discovered. But this arrangement required certain reformation, as this method could not explain the positions of certain elements, rare earth metals and isotopes. To remove these defects, Moseley in the year 1912 arranged the elements in increasing order of the atomic numbers, and this table is called the modern periodic table. According to him, the properties of elements are the periodic functions of the atomic number. Finally, Niels Bohr gave the extended form of the periodic table known as long form of the modern periodic table. The present periodic table looks like this, which is arranged on increasing order of the atomic numbers. Hoping that today's elementals are deeply embedded, we encourage you to take up the self-check assessment. This segment is specially designed to test your understanding of today's lesson. Explain Newlands law of octaves. Also mention the cause of its rejection. What is the basis of Mendeleev's periodic table? The properties of elements are the periodic functions of their dash. The solutions of this segment will be discussed after we complete the entire chapter. You can post your queries and doubts in the comment section. And if you like the video, do hit a like. Meet you in the next video with a new episode. Till then, take care and study hard.